And our last speaker, who is already on the stage, is the Director of Data Science and Analytics at Wellthy, a health tech startup revolutionizing the way families care for their loved ones and themselves. She's on a mission to build a world-class data team that can empower employees and partners to make better decisions with data. And today, she will help us to unleash the power of analytics engineering. So please welcome Kelly Burdine.
All right. Well, thanks for having me. I'm very excited today to talk to you about how analytics engineering has really helped me and the teams that I've led make a big difference in the organizations that I've been a part of. And I realize I'm like the last thing between you and free drinks, so thank you all for being here. I really appreciate it. I know it's been a long day. I'll try to make it interesting. All right, so for those of you who've been working in data, you've probably heard of the term analytics engineering. It's kind of had this like meteoric rise the past few years. Everyone's talking about it. But 10 years ago, this term didn't even exist. Nobody had a role of analytics engineering. No companies had analytics engineering teams. It wasn't there, right? And this kind of came about because of the rise of the modern data stack. It suddenly became a lot easier for teams to ingest a lot more data more quickly. You could do more interesting things with data. And so obviously different problems arise, and there's kind of a need that arises. And that's kind of where analytics engineering started to take shape. And so some of you are probably wondering, like, is it all just hype? Is this really just a data engineer with a different title? And so, I've been using analytics engineering at a few different organizations now, and it's actually been a big difference maker for me. So I'm going to talk about that today. All right. So we're going to go back to when kind of analytics engineering was coming about. At the time, I was leading a data team at a sports technology company, and we had really embraced the modern data stack. But honestly, I was a bit naive on what it took to build like a scalable and reliable data function. And so I kind of thought I had all the pieces in place, everything to be successful. We had a cloud data warehouse where we centralized and stored all of our data. We had automated ETL pipelines, putting raw data into the data warehouse. We had a modern cloud BI tool. We gave access to everybody in the company. I ran some training classes on how to query and visualize the data. And so I'm like, awesome, we can do data democratization, self-service analytics. Everybody's going to use data. It's going to be so great, right? And so here I am thinking I had everything I needed to be successful, and I was going to deliver all these powerful insights to help the business, lower churn and save cost and improve the user experience, increase revenue, right? And so for a short time, it kind of worked, right? I was helping leaders make better decisions. People had access to data and information that they never had before, and that was great. But as you can probably imagine, problems started to arise. And so I bet there's a lot of people in this room where some of these problems seem very familiar, right? I see some heads nodding yes. Okay, so we often had cases where data would just go missing, or suddenly it doesn't look correct, right? We were dealing with slow data refreshes, and when you can't get data fast enough, you can't analyze it fast enough, and you can't get it in the hands of decision makers before they need to make the decision. We saw metrics in company dashboards like suddenly changing from day to day, and we're like, what happened? I don't know. Not a good thing, right? Inconsistent values across reporting. I think we've probably all seen that, where you go to the meeting and the marketing person says, I think it's this number, and the product person's like, wait, that's not what I have, that's not what my dashboard says. And you're trying to sit there and figure out what the heck the difference is. All right, nobody wants to be there. And ultimately, like, our business questions were really hard to answer. Our analysts were spending almost all their time just like cleaning and prepping data and hunting down problems and building basic reporting. And stakeholders were really losing trust. Right? The data is changing. I don't know if this is right. I don't know how to use it. I really need an analyst to help me, but the analysts are all bogged down. And so what happens? Decision makers aren't using data. And that's how a data team delivers value, right? We have to be using data to make decisions. We have to be taking action. If you didn't see Emily Sherrio's talk earlier about data alone is not enough, I highly recommend it. She talks about this exact thing, about how it's really important to take action, right? And so this was kind of a harsh reality for me. It's like, oh my gosh, we're a cost to the organization. We're not delivering enough value because not enough people are using this data to take action. And this is actually a really common problem that's out there. A few years ago, Harvard Business Review did a survey, and almost every one of the Fortune 1000 companies that they surveyed said they were investing in data, but only a quarter of them were actually, achieving their kind of vision of being data-driven and using data to make decisions. So, at that time, I wanted to believe there was an easy solution. We just didn't have the right tools, right? I tried new tools. We don't have enough people. I'm just going to hire more people, throw people at problems, right? Changes to the sprint process iteration. But none of it was really working. Everything kind of felt like an uphill battle. I didn't really know what was going on. So I kind of started to take a deeper look at the problem, analyze it, and say, what are the root causes? Like, what is really causing this? And I realized we had a lot of very manual, repetitive, and error-prone processes. Our analysts, for example, were writing the same SQL over and over again for every report that they were building. And it's really hard to remember a bunch of business logic and transformation. And then if you need to make an update, you have to go update it in every place, right? That's not scalable. And that's where a lot of these problems were stemming from. And these processes don't scale well with more people or more data. And we also were kind of getting away from really understanding the business problem. Luckily, around that same time, there were some very smart people in the data world, smarter than I am, who said, wait a second, this isn't unique to data. Software engineering has these same problems. And they're a lot much more mature than kind of the modern data team is. And they've already developed a ton of best practices on how to solve these issues. So why don't we just borrow this and start implementing it in the data world? And so this is kind of where analytics engineering came from. It's sort of a mashup between an analyst and a software engineer. So let me kind of paint a picture for you, okay? This is a common analogy that gets used for analytics engineering. I can't take credit for it. I'm not sure who originally came up with it, but I think it's really good. So let's say you want to check out a book, maybe a mystery novel, okay? So you go to the library. Library looks like this. Yikes. Okay, are you going to find the book that you're looking for? Probably not. You might poke around a little bit. Maybe you'll come across a title that kind of sounds like it might be mystery, and you're like, oh, maybe this is good. You might get lucky, but chances are you're probably not going to walk away with what you're really looking for. Okay? And if you're trying to recommend something to someone else and you're trying to describe to them how to find it, right, that would be really hard. Someone takes a book off the shelf, everything falls, the order changes, it's a mess. All right? But libraries don't actually look like this, do they? No, they don't. There's librarians who curate all of the resources at the library, and they organize it in a way that makes sense based on how people are going to search for things, okay? So if you're doing research and you need to pull a bunch of nonfiction stuff, right, the nonfiction is all organized by subject and tagged accordingly. If you're looking for fiction, right, it's organized by author and genre. The Dewey Decimal System, right, I can go into just about any library in the world and I can quickly locate a book. I know how to find it, right? I can get in and out. And that's what librarians do, right? They make it really easy. They're not the ones writing the books. They're not the ones, putting together the research or whatever, but they're curating it. They're making it easy for all of us to consume that information and do what we want with it. And that's what an analytics engineer is like. They are like the librarian, and your data stack is the library. So, like librarians, analytics engineers, again, they're not creating data sources, but they're ingesting all the relevant data sources because they are close to the business problem. They should know how people are searching for it. They want to know what questions people are asking, right? And they're organizing those data sources in ways that makes most sense to the analysts and the business users. And so they maintain that organization. They document everything. They have definitions for everything. They train people on how to use it. They're there to answer questions. And they're going to apply software engineering best practices to build that data stack that's going to scale well. So as you add more data, as you add more people, as your organization grows, you want it to scale with it, right? And so here's some of the examples, like automation and CI/CD. All right, so going back to my story, right? I got all these problems. I discover analytics engineering is a thing. I'm all excited. Coincidentally, at the same time, I get recruited to go work at a company called Owla to start up a data function there. So I'm like, wow, what a great opportunity to kind of start something from scratch and implement all these things that I'm hearing about. And so I went there and I started building this stack out and these practices out with analytics engineering in mind. I iterated a lot. I made a lot of mistakes. I learned what worked, and I built out a data team, and I built out a data function, and I was so surprised, like, how much of an impact it made. It was a huge difference. And then last year, I switched over to Wellthy, which is my current company. They had an existing data team. I went in there, and guess what I found? The same problems I had seen at the other companies, okay? So I'm like, wait, I think I know how to solve this. I implement the analytics engineering best practices, and again, seeing really good results. So what are those results? Well, we went from missing incorrect data, now we have really accurate and reliable reporting. We have robust ETL processes. We went from, I think, refreshing the data like maybe once a day. We're doing it every 2 hours now, and only because people don't really need data more often, we could do it more often. We have consistent reporting with data lineage. We have our analysts are focused on actually analyzing data. They're not just cleaning and prepping data all the time. They are not hunting down problems. They're not just building reporting. Reporting is a piece of it, but they're spending a lot more time actually analyzing it and delivering insights and working with the decision makers. We have business users exploring data on their own, and we have people making decisions with data. Yay, that's what we're all trying to get to, right? So this was so exciting to me. So hopefully at this point, I've convinced you that analytics engineering is worth a try. But how do you go about implementing all of it? So I'm going to walk through some of the things that I've done, some of the things that have made the biggest difference when we're working on teams and having the best outcomes. And I realize like every data team looks a little bit different. Sometimes you're a data team of 1, sometimes you're a data team of 20. But I think a lot of what I'm going to talk about is really applicable no matter what your data team looks like. All right. So one thing that's so great about the modern data stack is it's actually really easy to kind of get up and get started. And that can be both a blessing and a curse, because it also means that these tools are so flexible and easy that it's also really easy to set it up incorrectly. All right, and you're kind of blocking yourself by doing that. And it creates a ton of tech debt, because like software engineering, there's a lot of dependencies, right? Think in data. If you want to go change the name of a column, you might break all your downstream reporting. Just a simple change, okay? And so you want to make sure you set these tools up correctly. And so, I'm always surprised when I talk to people who aren't getting a ton of value out of their tools, like, hey, I'm having a problem. I'm always surprised by how often people don't stop and take the time to like learn the tool and understand how it works. So the first thing I always recommend is like read through the documentation, right? These companies want you to be successful with their tool, so they're going to create a lot of documentation around it. Another great way to kind of learn the best practices of the tool is to ask questions in data communities or at conferences, right? A few weeks ago, someone actually reached out to me in a Slack community that I'm in, said, hey, I heard you use this BI tool. We're thinking about implementing it. And he asked, what's one thing you wish you knew about that tool before you implemented it? I think that's a great question, right? Because it's really hard to fully understand a tool in like a 2-week free trial. And so, I was able to very quickly answer this person's question. And there's lots of other people out there that are willing to kind of share information. Now that some of these tools have been around for longer now, there's a lot of blog articles about best practices and how to do things. So, Google away. Naming conventions. I can't speak highly enough about naming conventions. My team and I have a joke about like naming things is the last like unsolved problem in the world. Naming things is so hard, and it can really bite you in the butt later on, right? If you keep things named consistently, it keeps everything organized. It makes it easier for people to find things. So it's really important that you have good naming conventions. So work together as a team, decide on naming conventions, stick to it, document it. Also, always asking yourself what could change in the near future. I think sometimes people get so focused on solving like the current problem that they lose sight of like what might be different in 6 months or a year from now. Right? And then you want to prioritize necessary changes. So I realize like a lot of you might not be getting the most out of a certain tool, and you might already have it implemented. So we're not always talking about implementing a new tool from scratch and doing this. And so sometimes that's hard. That's a really hard thing to be able to say, this is already kind of in our data stack, in our process, and I'm going to now change things. But I promise it's worth the effort. You want to make sure you're getting the most out of your tools. All right, so how many people here have had a data source change on them and break your downstream reporting? Raise your hand. Yeah, OK, a lot of people, right? How many times have you had a business stakeholder reach out and say, this number doesn't look right? That's like the analyst's worst nightmare, right? You're like, oh, no, great. Yeah, it happens all the time. And this is where automated testing can really help out. If you're not familiar with automated testing, a test is really just a piece of code. It's an assertion about how your data, your model, your metric should look, right? So if X, basically, write code says if X says this, it must be true, right? And if X isn't true, the test will fail, and it'll alert you. OK, so you can see some examples here on the right-hand side of some of our testing and some of our alerting we have set up at Wellthy. And so that's kind of how testing works. And you can actually start doing this manually, right? You can start writing scripts and just manually running them if you can't automate them at first. That's like one way to kind of get going and start figuring this out and help yourself out. You always want to make sure you set up alerts, too, especially once you start automating it. You want to be notified ahead of your business stakeholders, right? You don't want that person coming to you and say, this number doesn't look right. Like, I want to know my number's wrong before they do, right? I want a chance to fix it before it ever reaches a decision maker. When you're writing tests, you want to make sure your tests are meaningful. We don't just write tests just to say we have tests, okay? Writing tests takes time. Running tests takes time. So you want these tests to be meaningful. You don't want just a bunch of junk in there. There's a lot of great tooling out there now that have testing. So like DBT is an open source tool. It comes in with built-in testing. There's also data observability platforms like Dataful, Monte Carlo, Metaplane. There's a whole bunch of them. And then the last thing around testing is watch out for test failure fatigue. This is when the criteria for your test failures is too low, and so you have lots of things failing all the time, right? And so you want to make sure that when a test fails, it's something really important. Your team prioritizes it, addresses whatever the issue is. If you have a bunch of things failing all the time, you kind of start to ignore them, right? And pretty soon, you're going to miss one that's actually important because you're not actually checking all these failures every day. So watch out for that. All right. So probably one of the biggest, most important things with analytics engineering, is implementing a continuous integration, continuous delivery process. So if you're not familiar, this is the idea that you're constantly making changes to your code base, usually in kind of smaller increments. You're testing them in a separate environment. You have everything version controlled. You're deploying to production. And then you're just kind of repeating that process. You're doing it over and over again. And a good CI/CD process is going to be automated, and it's going to feel seamless. And this helps reduce a ton of errors and bugs in your code. It also speeds up the development process. This is a pretty key piece of analytics engineering. All right. And so this is kind of what it looks like, right? And so if you don't have anything set up like this right now, this can probably feel kind of daunting. Like, where do I even start? Start small, right? You don't have to go for the whole thing at once. That's OK. You can take baby steps. So the first thing you want to do, first of all, never make a change in production. Whether it's a production dashboard, production transformation code, whatever it is, don't make a change in production if you don't have this set up. So start moving that out right away, all right? Make a copy of something, test it there, then push it over once you've kind of confirmed it works. This is also a really good time to start incorporating peer reviews. So GitHub, GitLab make this really easy to have code, do peer reviews, and this is where you can start catching stuff and incorporating that into your process. Next, add version control. All right, you want to always be able to quickly revert your changes. So if you push out a change, something breaks, automated test fails, something's going on, right? You don't know what it is. You want to be able to quickly roll back, troubleshoot the problem, right, and then go fix it, right? You don't want your end users affected that whole time while you're hunting down the change. So version control is very important. Also, this isn't technically part of CI/CD, but this is a good opportunity to really start breaking your code into smaller chunks. So if you're one of those people out there whose team has like a SQL script with hundreds of lines of code, I get it. I've been there, so I know there's more people out there that have done this. It's really hard to like edit and update those without breaking something, right? So breaking code into smaller chunks and using the dry principle, which is don't repeat yourself, that makes things so much easier to test and to make changes and to push into production, right? So this is a great opportunity to do that. Also creating a testing environment. So at Wellthy, what we have today is each person on my team that is developing has their own like branch schema in the data warehouse that gets created. There is a PR schema as well. So none of that data is mixed with production. And you can always compare branch versus the production. We have this whole separate environment. So that helps. That really helps the process and helps you test and make sure that when you push those changes out that you feel confident about what's going out there. And then finally, of course, automating this. So there's a lot of tools out there that help with this, a lot of orchestrator tools. dbt Cloud has a pretty slick way to do this. And so it probably feels daunting if you're starting, again, from square one. But I promise there's a lot of ways to do this, and you can kind of break it apart, too. All right. Good documentation is so important for scalability and knowledge transfer. Documentation allows your end users to really understand the data and the metrics without needing to involve the data team. Think back to our librarian metaphor, right? Like you go into a library and yeah, you might need some help once in a while asking, but like for the most part, you can find what you need and you know how to do it and you can go in there, right? It is so important, right? I'm leading a data team. I'm not always doing the analysis. I'm not always in the data, but I can go into our documentation and I'm like, what is that column called again? I can't quite remember. And I can kind of search, comes up. I can see the definition. I can see nuances about the data. I can see sample data, right? It's all documented right there. And so I can very easily kind of get going without having to involve a bunch of the people and slow things down. I can get to the data faster. Documentation is also that thing that like everybody values, but nobody really wants to do it, right? And so it can be kind of tough getting going and documenting all your stuff. And so I guess first, like, what am I talking about when I say documentation? Like, what are we documenting? I guess the short answer is everything. Your data sources, your table definitions, your column definitions, metrics, your team processes. Honestly, you really want to document everything. If I hire a new data analyst, I want them to be able to come in and go into the data warehouse, and I give them a question, and they can kind of figure it out and start querying the data. If I have a business user that's going into our BI tool, I want them to be able to easily figure out what's the correct report to use. That's what we're striving for. That's the level of documentation we want. We're not all going to be there, right? That's sort of a perfect scenario, but that's what we're trying to go for. And so where do you start, right? Well, you start with your most used data assets, okay? So this is that dashboard that everybody uses, or this is that main data model that, fuels all these other metrics, right? Start with your most important ones, kind of prioritize that way. Make documentation part of your definition of done. Every time you touch a transformation script, say, it's not done unless everything is documented in it. If you go make an update on a report or a piece of analysis, it's got to be documented. making it part of your definition of done and holding each other accountable, you'll be surprised. You quickly build up a pretty robust documentation, okay? Doing it that way, and you just kind of chip away as you go along, right? Like no team has time to say, hold on, we're just gonna pause all work for a month and just spend the time documenting. So you really kind of have to chip away at it. But you'll start to realize the benefits. Keeping it as centralized as possible. I know sometimes it's hard to like truly put everything in one spot. There's a lot of data catalog tools out there like Atlan and Data.World that are trying to do that. Some of them are expensive, some of them are a little cheaper, but we don't always have a data catalog, and sometimes it's honestly like, depending on the size of your team and organization, it might not be worth it, but you do want to keep it as centralized as you can, right? If it's dispersed amongst a bunch of different sources, it's going to be really hard to find. It's going to be really hard to maintain. So you don't really want to do that. So at Wellthy, we do most of our documentation for our data assets in dbt. Those get exposed automatically in our BI tool. We have some of our other stuff around our processes in Guru. But yeah, it's really just kind of those two places that we keep everything. All right. Getting close to your business users. So again, you really want to understand the business problem. When I first started at Wellthy, I noticed that our analysts were writing the same SQL like over and over again in every single report. So I asked my engineer, I said, can you move some of this logic to our transformation layer? That way it's just done once, right? We're not doing it over and over again. They don't have to memorize all these things. It'll make it easier. And so he was like, yeah, sure. So we looked at the reports. He put everything in the transformation layer, and he pre-aggregated everything to, I think, like a monthly level or something, and by some other dimension. And so it did make it easier for analysts, but then the business user came and said, you know, I'd like to be able to see this year over year so I can see how this trend has changed. Well, it was pre-aggregated, so we couldn't really do that. And so we had kind of missed the point of what decision they were trying to make and what they were trying to do with it. And so I think it's really important for whoever's doing the analytics engineer, whether it's an actual engineer or maybe it's some data analyst, to make sure you're really close to your business users. Now, a few tips on this, because sometimes it's not always easy working with business users. They often don't know what they need. They often don't know the right questions to ask. But there's a few things you can kind of keep in mind. One, get into talks with them. Participate in handling data questions. A lot of times you get questions in Slacks or Teams, right? Have your engineers answer those questions too, and get familiar with what kind of questions they're asking. Make your request process transparent. So here's kind of a snippet of our request form. You'll notice some of the questions we're asking are really around, it's not just like, what do you want? It's what decision are you trying to make, right? And make that really transparent. That goes into our Team Slack channel. Everybody sees it. Everybody can see exactly what the person is trying to do. Keep asking why. So they might say, hey, I need a list of clients who've done X, Y, and Z. Well, why? Oh, I'm running this marketing campaign. I need to send this. Why? Right? Like you'll eventually get to the decision they're actually trying to make, and then you can make a better recommendation as to what you need to do. All right. Getting familiar with the BI tool. So your BI tool is the main way that pretty much everybody in your company is going to interact with your data. And all BI tools have limitations, right? Some don't handle nulls very well. Some have limitations with joins. Some can't use OR filter logic, right? Like there's all these things. And so if you don't know that as an analytics engineer who is trying to curate all this data, and to answer questions, like you're going to end up with a problem, right? Because you're going to put it in there, and then it's not going to work the way you thought it was going to work. So I recommend like having your engineers periodically fulfill requests in your BI tool. So like answering questions just like the analyst would, or just like your business users would. Get them involved in those tasks. Before building on a new data set or making a change, test it with sample data in the BI tool. So here on the right, we actually just built this pretty large new data model around calculating member engagement. And you can see like snippets here of what my engineer did, where we try to model out exactly what it's going to look like in the BI tool, how the joins are going to work, how the metrics are going to work. Here's some code for how the formulas are actually going to work. She threw some dummy data in there. She tested it out to make sure it would work. It saved a ton of time, right? And then we know, and that's all before we even start to code. Okay, so that's a great way to kind of test out and get familiar with that BI tool. The last thing here is training your data analyst. So a lot of analysts might not be familiar with software engineering best practices like version control or testing. These are new concepts. So you want to make sure that they understand the process that your team is using, that your engineers are using. Otherwise, they're not going to be able to communicate and collaborate very well. They're not going to be able to help troubleshoot and really communicate the needs and the requirements. I've actually sent all of my analysts through a basic analytics engineering course and saw pretty good results. I'm not trying to make them Python experts or make them analytics engineers or doing all this stuff, but now they really understand what we're doing, right? And they can participate in the version control. They can talk to the analytics engineers and understand like what's happening and where problems might be and offer up recommendations. So I highly recommend training your analysts, at least on your own data stack and processes and everything. All right. So hopefully I've kind of convinced you analytics engineering can really be a big difference maker. It solves a lot of the common problems that we see in the data world. Tools are helpful. Tools can definitely help facilitate things, but really adopting those engineering best practices, that's what the difference maker is. That's what has been so crucial to success on the data teams that I have led. When you're implementing these, start small, keep adding, right? You don't have to do everything at once. That can be overwhelming, and you want to iterate. You want to see the impact of each of these changes. Stay close to the business users. You want to make sure you really understand the problem you're solving. And remember that data being used in decision making, that's your best measure of success. All right? If people aren't using data to make decisions, you're not there yet. Keep going. All right. Thank you. I'll open it up for any questions.
Now both of us are the last thing between people and the free drinks,
Yep.
right? But let's still have some questions. We have at least 4. How would you cross the line between roles like analytics engineer, data platform engineer, etc.?
Yeah, so honestly, there's not really a distinct line. There's overlap, I think, between some of these roles. And I also don't think the titles necessarily matter all that much, right? So I have a data engineer, that's his title on my team, but he's really acting more like an analytics engineer, and I think that's fine. But yeah, I would say kind of the short definition is data engineers generally are building more custom ETL pipelines or back-end data stack stuff. Your analytics engineers, again, are curating those data sets, transforming them, making them available and really easy to use for analysts, and your analysts are building reports and doing analysis.
All right, thank you. Aren't some of the mentioned steps better suited in earlier phases of the data process?
Yeah, sure. Like, a lot of the things I recommend are definitely easier to do early on, but that doesn't mean a more mature data team can't benefit from a lot of the things we talked about today. And so, I think it's important to always iterate and improve and identify like where you might be having problems and figuring out which of these things would help get you there.
Thank you very much. Which BI tool does Wellthy use, and how is documentation from DBT automatically exposed to it?
We use ThoughtSpot. It has an integration with DBT, so when we import our models from DBT in our cloud data warehouse, the definitions actually come with it. There's other information that can come too, like freshness tests and stuff, and there's a few other tools that do that. Mode does it, Metabase does it, I think Looker does it. So yeah, I would definitely look into your BI tools and see which of them incorporate DBT.
And now 2 questions from potential candidates. How would you recruit an analytics engineer? What would you expect from a candidate?
I love this question. Sometimes you can find analytics engineers in unlikely places. This is a relatively new discipline, so people don't always have that title, all right? So it can be hard to find someone that has analytics engineering experience listed on their resume. But I've hired people from all different industries, all different backgrounds, And it's people that have the right mindset, right? And understand the benefits of like the software engineering best practices. I wouldn't focus so much on, oh, do they have experience with these specific modern data tool stacks? As I mentioned in my presentation, these tools are actually pretty easy to get going, right? So I think a lot of people can learn them. I don't think that's really the barrier to entry is like, well, do they have experience with DBT or Fivetran? Like, I think they're really easy to learn. So you want people that, obviously, they need to have strong SQL skills, and some type of analytics background is really good. But again, think outside the box, and you'll find some great people that have coming from other roles.
And what kind of roles do you have open now?
I wish I had some roles open right now. I don't have any roles open right now. Probably the next role I'll have open is a product analyst, and then another engineer coming down the road.
We will watch your LinkedIn profile.
Yes.
All right, and last but not least, do you think that your principles and ideas can also be applied to data science team, for example, in ML Ops?
Yes, I do. You know, it's interesting because I think a lot of people thought machine learning was like that's this really difficult problem, and honestly, it's not that difficult anymore. The difficult part is how to deploy machine learning in a production environment, and constantly getting new input data and having it learn over time and change and update and you know, invest it in your product. And so I do think a lot of the analytics engineering best practices can be applied to ML Ops. I think they're very similar.
All right, and the very last one, I promise. How would you sell the idea of building an analytics engineering team to the CEO?
Another great question. I actually gave a whole talk on this last year about getting organizational buy-in and trying to convince your leadership to invest in data analytics engineering. So if you're interested, I can tell you afterwards where to find that talk. But I don't have 30 minutes now, so I think the short answer is you have to start small and you have to start showing value. You know, you kind of have to take an MVP approach with it. You can't just say, well, I'm going to build out this whole thing and do all this stuff, you know, that I showed in the presentation. That's going to take a lot of time, and it's hard to get buy-in with that. So you start off by trying to tell your leadership, like, hey, here's how this can benefit you. Here's how this can help the organization generate more revenue or save more expenses or whatever it might be, right? Like, you have to frame it and how it's going to help the organization, and then start small and start showing value. And you'll get more and more buy-in as it goes along, and that's kind of how you sell it.
That's a great universal advice for pretty much any new implementation in a company.
You're right. It's not just true for analytics engineering. It's kind of any new initiative, right?
All right. Thank you so much, Kelly. Please, let's give a warm hand to our last speaker of the day,